speaking about reading Shakespeare with Python. Words, words, words. Ethan, welcome.
Oh, hello, hello. It's a little better. Great. Hi, everyone. My name's Adam. I am a software engineer at edX. That's a nonprofit company that puts college courses online, mostly for free, and we're open source as well. I'm really, really excited to be here today. I'll be giving a talk called Words, 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 Reading Shakespeare with Python. So before I talk, I'm going to give a little background about myself. I'm a software engineer. I also have a really deep love of literature. Not that these things should be mutually exclusive at all. But when I was learning how to code, I was really, really excited about the possibilities of applying these algorithmic techniques to understanding text, trying to see where the intersection between text and algorithms lay. So in this talk, I kind of want to give an overview of things that you can do with text with Python. So the first part of the talk, we're going to ask a question. How can we use Python to supplement our reading of Shakespeare? In this part of the talk, we're going to see, like, what are some things we can learn about Shakespeare that we couldn't otherwise figure out just by reading him? So here we're going to do a lot of, like, statistical analysis and other kind of techniques to get this kind of information out of the text. In the second part of the talk, we're going to ask a little more ambitious question. How can we get Python to read for us? Obviously, this is a very ambitious task, so we're going to scale it down a lot, and we're going to build a text classifier. And what a text classifier is that it'll take a piece of text, and it'll give you some information about that text. So in this case, we're going to build a genre classifier for Shakespeare. What that means is that we're going to take a speech, feed it to the classifier, and the classifier will be able to tell us if it came from a tragedy or if it came from a comedy. If you've gotten this far in this talk and you're a little worried because you're like, oh, great, now I got to listen about Shakespeare for the next 30 minutes, don't worry. All the techniques we're going to do, we can apply to anything else. So every time I say Shakespeare, think Twitter. And when I say genre, think sentiment analysis, because it's the same thing. But I think this is a more fun way of going about it. So, first part, why are we using Shakespeare? So when I was doing the research that became this talk, I was thinking about this question, and I came across this scene from Hamlet, or I remembered this great scene from Hamlet. Hamlet is reading a book, actually. He's dressed melancholily in all black, and Polonius, who's his sort of girlfriend's dad, who's spying on him for his mom. It's really complicated. But the important thing to know is that he's reading this book, and Polonius asks him, what are you reading? Hamlet replies rather flippantly, words, words, words. And Polonius presses him, what is the matter, my lord? I mean the matter that you read, my lord. And I thought this was sort of a nice way to frame the talk, that a computer can look at text, and to it, without any added stuff, it's just a series of words. And we want to figure out, we want to press that a little deeper. We want to figure out, what is the meaning of the text? So I thought that was a nice way to frame the talk. The other reason we're using Shakespeare is because he's been marked up in XML already. So there are some brave souls at PlayShakespeare.com who have marked Shakespeare up extensively in XML. This is going to be a huge win for us because we don't have to do any of the dirty work of cleaning Shakespeare up to be analyzed with Python. It's just all right there. So if you want to see what Shakespeare XML looks like, here's that line, words, words, words. Tons of metadata associated with it, who the speaker is, what line number is, and so on. Here's some more metadata of information about the play as a whole. It's really interesting stuff. You can go look at it. So before we get too into it, I want to go over what are some challenges of doing text analysis. The first one is the main one. Language, and English is a particularly bad offender, is really messy. The rules are really unclear. We all sort of know these things, and often the way English is written doesn't directly correlate to its meaning. For example, apostrophe S's can be either possessives or contractions. So you can say Adam's talk is really great, or you can say Adam's really screwing up his talk right now. In both cases, Adams is spelled exactly the same, but have two very different meanings. Another thing is that texts are usually unstructured. So if you want to analyze, say, a New York Times article or something, you'll probably have to scrape it, figure out where the actual article is, find out where the metadata is. We're usually not this lucky to get all our structure handed to us on an XML silver platter, as we're doing in this case. Another thing is pronunciation isn't standard. So at some point in this talk, we're going to talk about some of Shakespeare's rhymes and how to look at those. But unfortunately, the sound of a word is not encoded in the way that it's written. And it's even worse because, I'm from Boston, and people in different parts of Boston don't pronounce words the same. In England, they have all sorts of ways of pronouncing stuff depending on different regions, and now we're going to compound that by going back 400 years to Shakespeare's times. There are actually lots of puns that are rather not safe for this conference that only really come out in Shakespeare when you understand how he was actually pronouncing these words. And the last challenge is that reading is hard. Everyone here is probably pretty smart, and it all took us 6 or 7 years to even get the basics down of this thing. So we're going to expect our computers to do this pretty quickly in just a matter of milliseconds. So that's another challenge we're going to face. So definitely humans really have this edge when it comes to reading because we've been doing it for so long and we get all these nuances. So I want to go over some things that play to humans' natural strengths and computers' natural strengths when it comes to doing text analysis. Something that humans really excel at are understanding nuance and ambiguity, all these tasks of close reading. While computers, on the other hand, are much better at these repetitive tasks, doing lots of counting, making graphs and stuff like that. So it turns out that in the late 1900s, Shakespeare was the subject of one of the early statistical analysis of text. And what this guy did, this mathematician, is he looked for all the words that only appeared once in Shakespeare and tried to figure out if when these words occurred, correlated with Shakespeare's best plays, Macbeth, Othello, King Lear, the ones we consider his truly great works. This must have been a horrible, horrible thing to do in 1896, to go through all the words and figure out what the unique words were in Shakespeare. Obviously, this is a pretty trivial task in Python, so this is something that we really have going for us. One way to think about this talk is that in the first part of the talk, we want to bring this right circle to the left circle. We want to leverage the things that computers are good at to help us do what we're good at, understanding the nuance and ambiguity in Shakespeare's text. In the second part of the talk, we want to bring what humans are good at and bring it to computers, get computers to read with admittedly a very, very crude degree of nuance, but some discernment nonetheless. So one of the first things we can do with text analysis with Python is we can look at metadata. And just to get a cursory overall look at the plays we're looking at. So something that's always interesting to do is to look at who has the most lines in a given Shakespeare play. And usually you would think that the person with the most amount of lines is the most important person in the play. So something we can do is we can actually test this hypothesis pretty straightforwardly. So we might ask, who's the main character in Hamlet? And if you look at these graphs, it's clear that Hamlet has by far the most amount of lines in Hamlet, more than twice as much as the next amount of to the person with the next most amount of lines. In King Lear, we see the same thing. Anyone want to guess who has the most amount of lines in Macbeth? No surprise there, it's Macbeth again. And Othello? Nice try. No, Othello does not have the most amount of lines in Othello. And this is kind of an interesting thing to look at, that actually Iago, who's the villain who engineers Othello's downfall, he has more lines than Othello in Othello, so he's usurped Othello from his own play. This is kind of an interesting thing to look at, just to give you an overview of what's going on in the play. Here's a detail of that graph. Of course, the most important thing we can do with metadata in Shakespeare plays, and probably any kind of analysis at all, is, and this wouldn't be a talk in 2015 without this, is we can make Shakespeare social networks. Obviously, this is just the edges are how many times characters appear in the same play as each other. And I can't pretend to know anything about graph theory, but I thought this made for a pretty good joke, at least. All right, so now let's start looking at actual text. And here we're going to look at Shakespeare's most interesting rhymes. And here we're going to look at Shakespeare's sonnets. And I don't know if you guys have ever had to look at Shakespeare's sonnets, so let me give you a brief overview of what a sonnet is. So at its heart, a sonnet is a 14-line poem. It's actually possible to have like 13 or 15-line sonnets, but there are approximately 14 lines. Very popular in the Renaissance when Shakespeare is writing, and they can have many different rhyme schemes. Something that's really nice is that Shakespeare is probably unique among all poets in only choosing one rhyme scheme for all his poems. This is huge for us because now we don't have to figure out algorithmically how the words rhyme with each other. All we have to do is hard code the rhyme scheme into our algorithm. Here's what the rhyme scheme looks like. You don't have to read the poem or anything. Just trying to give you a sense of what that looks like. So this is huge. Again, we skip a hard part by knowing that Shakespeare is being consistent. It was very considerate of him to help me out with this talk 400 years ago. So now we want to consider what are Shakespeare's most interesting rhymes. And the way we're going to do that is we're going to look at different kinds of rhyming distributions. What are the various frequencies of Shakespeare's rhymes? And here we're going to use two tools that the Natural Language Toolkit, which is Python's natural language processing library, affords us. The first one is a frequency distribution. And a frequency distribution will help us answer what are Shakespeare's most common rhymes in the sonnets. The way a frequency distribution works is it takes a series of objects and it tells you how many times each object appears in that series. The second thing we're going to use is a conditional frequency distribution. This is a little more abstract. I'm going to have examples in a second, so it'll become clearer. But what this will help us do is it'll answer the question, given a word, what is the frequency distribution of the words that rhyme with that word? So let me illustrate these things with a couple examples. First, let's look at the frequency distribution. And here we feed all the rhymes in the sonnets in the frequency distribution, and we get a dictionary actually of the rhymes and how many times they appear. So you can see the most common rhymes in Shakespeare's sonnets are thee and me and thee. This is hardly very surprising because the sonnet form is and Shakespeare's sonnets in particular are very concerned with there's a speaker always addressing a person. So it makes sense that me and thee appear so often. So let's jump into conditional frequency distributions. So we know that me and thee is a very common rhyme. But what if we now want to know what words rhyme with thee and how often do those words rhyme with thee? So we can use a frequency distribution to answer that question. And here we print out all the words that rhyme with thee. And you see, unsurprisingly, me rhymes the most often with 23 total times. But as you get toward the tail, you start getting some really surprising and interesting words. Thee rhymes with melancholy, posterity, usury. These are much more interesting words, and the frequency of which they actually rhyme with thee reflect that. And so we sort of have two kinds of interesting rhymes here. The first one are these so-called, I call them boring rhymes. These rhymes between me and thee. In information theoretical terms, these are very low entropy rhymes. When you see thee, it doesn't add much information to say that the next rhyme is going to be me. In fact, if you read a Shakespeare poem and you see, indeed, like the last word of a line is thee, you're somewhere in the back of your mind, you're going to be expecting me to come next. The next kind of rhyme is the next kind of interesting rhyme are these lopsided rhymes, like thee and usury. This is of much more informational content here, and it's very surprising. And indeed, like usury, a word associated with money lending in a love poem is a much more surprising result. Okay, so now we're going to jump into writing code that reads. And here we're going to talk about how to build and indeed write a text classifier. So remember we said our classifier is going to tell if a given speech is from a tragedy or a comedy. Now if you're kind of worried at this point and you're thinking, well Adam, what about the tragic comedies? How do you even start with the problem plays? I'm just going to say, this isn't the MLA, this is PyCon. We're going to be all set. We're just going to ignore it. So I said before, classifier is going to take speeches and tell us information about the speeches. We might ask, how how does it know what information to get from it? Well, we have to train it. And the way we train it is that we give it we pre-label a lot of speeches. In this case, it's a trivial task because we have Shakespeare and XML. So we give it a lot of speeches that already have been labeled by its genre. And the classifier, and this is very high level, will start picking out what are the distinguishing features that make for a tragic speech and make for a comic speech. So a classifier has two main ingredients, the classifier itself and a vectorizer or feature extractor. And I really want to spend some time talking about vectorization or feature extraction because the classifier doesn't actually interact with the text itself. The text needs to be processed first. Features need to be extracted from it. It has to be vectorized before the classifier can interact with it. So what is a vectorizer? Vectorizer, or feature extractor, it transforms text into quantifiable information about the text. So theoretically, you can really choose anything. You can choose does capital letters appear in the text, does text end with an exclamation point. But what's really hard about this step is that it's hard to figure out what features to actually choose that will be correlated with the labels you want to predict about the text. So in practice, we start out with a bag of word model of vectorizing text. And what bag of words is you choose for your entire set of features the set of all words in the text that you're analyzing. And then you represent a single text by how many times each word appears in it. So this is a little abstract. Let me again illustrate this with an example. Say we have two texts, hello will and hello globe. So the first thing we want to do is we want to pick out what are all the unique words that appear in these texts. And those are hello, will, and globe. And then we go through each text and count how many times each of those words in this bag of words appears in each text. So we see in hello will, we have one hello, one will, and no globes. So what's happening is we're semantically we're transforming hello will into something that says something closer like, this is a text that contains one instance of the word hello, contains one instance of the word will, and does not contain the word globe at all. So we're losing a lot of information here, and we're really, because a lot of information is encoded in the order of words, grammar, all sorts of nuance. So we're really banking on the fact here that word use is very highly correlated with the label attached to the text. And by transforming this into features, it's going to make it easier possible for the classifier to interact with the text. So here's how a vectorizer looks using scikit-learn, which is one of Python's machine learning libraries. We import our vectorizer. We use count vectorizer, and that'll give us the bag of words. We do a vectorizer fit text, and that gives us the bag. And we can get the feature names, and we can transform the text into these vectors. And sure enough, this is very similar to what we saw on the slide before. Quick aside, why are these called vectorizers? These are called vectorizers because you can think of text, once you vectorize them, as points in a highly dimensional feature space. So where each axis is a word, you can think of a bag of word model as a point in this highly dimensional space of word bases. All right, so now we come to Act 5, which is the last act in a Shakespeare play. Now we're actually going to write a classifier and go through the workflow. So in this part of the talk, we're going to go into depth how the classifier actually works. And there are 4 steps to building a classifier. One, we want to, as I said before, in order to train the classifier, we need a lot of pre-labeled text. And what we want to do at first, we want to set a little bit of that text aside, usually 10 to 20%, so that we can use that to test our classifier, to make sure our classifier is performing, actually performing, because if we trained with all our data, then we'd have nothing to test our classifier on. Next, we want to vectorize our text, or extract features. We want to train the classifier, and so finally, we want to test our classifier. I want to drive this point home again. A really important workflow here is that the text turns into features, which then gets turned into labels. So the vectorizer turns the text into features, and the classifier predicts labels from the features. So here's kind of a diagram of the training workflow. You split our labeled text into 2. The vectorizer converts the text into features, and then we train our classifier with the features and the labels. All right, so let's see what this looks like. So first things, we want to import our count vectorizer. This will make our bag of word models. We also want to import our classifier. And here we're going to use naive Bayes classifier. This is very popular in text analysis. But what's nice about scikit-learn is that the API for classifiers are generally the same. So you can try out different kinds of classifiers as well. So we instantiate our vectorizer. We create the bag of word models. And we transform our training speeches into features. We instantiate our classifier. And we train our classifier. And that's really all it takes. It's only a few lines. And there we have our trained classifier. So now we want to see if our classifier actually works. So we're going to test this on the set of data that we set aside for testing. This is going to be the workflow. So something we want to do is look at a text. So we're going to take the first test speech. It turns out that it's a play from Titus Andronicus, which is an early tragedy by Shakespeare. And we want to assign its label. So now we transform this text to a feature, and we make a prediction calling the prediction method. And sure enough, it returns tragedy. So it seems like, at least for this n sample size of 1, our classifier worked. But say we want to look at all our, we really want to look at all our test data to make sure, to get an overall percentage of how accurate our classifier is. And again, scikit-learn makes this super easy. It's only a couple lines. We transform speeches into features, and then we call this score method. And in this case, when I ran it, I got about 75%, which isn't bad, better than 50-50, but it's also, it's probably indicative that word choice just isn't that highly correlated with the genre of a play. So some critiques of bag of words is that in order for bag of words to work, you really need a correlation between word use and the label. And this correlation is going to be stronger in some cases than others. It was there, but not that strong in genre. But if you think about like authorship, like say we were going to write a classifier to determine if a piece of text came from a Shakespeare play or like the iTunes terms of service, like that's probably going to be a pretty good classifier because they use a very different set of language. Something else you might want to be aware of is very highly disproportionate training data. When I was first doing the research that became this talk, I was really interested in seeing if speakers who were female spoke differently than speakers who were male. And the first round I'm creating this classifier, I got very high accuracy. But what it turned out that it was is that it just turns out that men speak about 9 times as much as women do in Shakespeare. And so you could actually write a classifier that just returned this speaker is a man, this speaker is a man, over and over, and that would be very accurate. But you're not getting any meaningful information out of that data. So that's all for my talk. I hope you enjoyed it. We got a computer to do a little bit of reading. It wasn't that in-depth, but it was much better than Hamlet's words, words, words answer. So thank you very much, and I'm open for questions.
We have 5 minutes. We have 5 minutes for questions. If anybody has a question, you can step here into the mic and do your question.
Was that clear?
I was wondering if you could elaborate on maybe some of the challenges or interesting questions that come up of analyzing dialogue-heavy text, like the Shakespearean plays versus like your New York Times example, which is not dialogue heavy necessarily?
That's a really, really great question. And obviously the one that's really interesting for Shakespeare, because Shakespeare's plays were never intended to be, or he wasn't thinking about printing them, he was thinking about having them spoken in a theater. And so that's very different. So suddenly things like punctuation don't matter at all. Like you might care a little bit more about punctuation in written down text, and the sonnets, which were absolutely intended to be read on paper. But yeah, no, this a whole difference of having an oral medium, and people speak different. People use different vocabulary when they speak than when they write. Like if I wrote this out and read it out, it would feel very different than someone actually speaking out loud. Let's talk more about this afterwards, because that's obviously a really deep difference.
Thank you.
Yeah.
Hello. Thanks
Hi.
for the talk. It's been good. I've been I've started using I have a little project in this field where I need to scrape web content and get what the content is about. For that, I think the bag of words might help a little bit, but do you have an idea of any other type of resources that I could use, like first pointers?
I'm sorry, or what was the last thing you said?
Any first pointers on where to look for this information?
Yeah, definitely check out scikit-learn. They have a really good tutorial on doing text analysis on their website. But I'm happy to talk more about that after. Come find me.
Yeah, sort of as a follow-up to that.
I'm sorry, can you speak a little louder?
Sure, can you hear me?
Yeah, yeah.
Just as a follow-up to that, do you have any suggestions for where to look for alternatives to the bag of words model?
Short answer, no.
Okay.
I think a lot of it is going to be just grit and hard work. You can look at NLTK. They have a lot of good resources for like parsing the grammar out of sentences, and you might be able to find stuff about that. But one of the reasons why we do bag of words is that at least there's no easy answer for what features to extract from a text. But it seems like in general, word choice is a pretty good indicator of things. Definitely there are better ones, but I think you have to arrive at them through more grit.
All right, thank you.
Hi.
Hi.
So actually, when I first heard this talk, I kind of kicked myself because I worked on a project pretty similar to this where we were analyzing character interactions in Shakespeare plays.
Oh, cool.
And so a big issue that we had when we first ran into it is that we didn't have structured text. So we just grabbed all of our text off of the Gutenberg.org website and ran massive regular expressions on top of it.
Oh, nice.
But like it's a common issue, especially in NLP, is you don't have a nice structured text set. Would you recommend any like tools around perhaps like trying to structure text or anything like that?
I don't have much more experience than you when it comes to this. Normally, I have to do crazy regex stuff when I take stuff down from Gutenberg as well.
Yeah.
This was just like a godsend.
Yeah, it's very nice. Cool, thank you.
So pick a famous enough actor, famous enough author that people are going to mark his stuff up in XML.
Definitely. Cool.
Any more questions? Oh, thank you, Adam. Thank you very much.
Thank you very much, everyone.
Oh, wait. There's
All right, one more question.
There's one question. We still have time.
Hello. So the XML that you used, how convoluted was it, or did you actually have to deal with XML at all, or you just dealt with the NLTK and scikit? So the XML input that you had for the Shakespeare, did you actually work with the XML parsing at all?
Yeah. I just used etree, LXML. It was pretty
just elementary?
Yeah. Just so that we could have something to parse it, and it made figuring out what text was associated with what metadata pretty straightforward. But you could also use Beautiful Soup or something. I just know etree.
Okay, thank you.
And I'm missing one.
Come find me if you want to talk more about this. I'd love to talk about it.
Thank you very much.
Thank you.